Alrighty. October, Sprint 2. Serena's Forest. So, ooh, this sprint was a doozy. First of all, some of the achievements. Major overhaul of the world canvas sizing system. I'll get into that in a moment. That was probably the biggest takeaway from this sprint. Some major performance improvements before and after that system was implemented. The tile revealing was made smoother. Um, the temperature system was made more stable, with a little less bouncy. So um, temperature changes don't like radically explode outward or anything. And the world canvas and temperature probe systems can be saved and loaded, which is kind of neat and fascinating and the start of something pretty cool, which should be implemented next sprint in its fullest. But I can show a little bit of it right now. But first of all, I cannot start showing this without going into a little bit of an explanation of the bug I encountered. Um, and this is a pretty fundamental bug that I um, had, what's the word for it? A giant oversight, let's say. From the beginning, so ever since the World Canvas was first introduced, its size was 1,000 by 1,000. That's 1,000 game units, 1,000 meters by 1,000 meters, and the resolution 2048 by 2048. All the textures, all 7 textures layered on top of each other, the snow, the ice, the dirt, whatever, what have you, all use 2048 texture scale. Um, Problem is, of course, the world, like all of the sections, the map, is way, 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 way bigger than that. Um, and from the beginning, when I introduced it, I thought, it was pretty easy to set the world canvas to 1,000 scale by 1,000 scale. So when I need to, in the future, when I have all those sections encoded and when they're ready to go, I'll just increase the size of the scale of the world canvas. Um, but there's a big problem with that. Uh, See, 1,000 by 1,000 works pretty well for 2048 texture scale. And it masked the underlying problem, which was if you scale it up. So if you, let's say, 1,000 goes to 10,000, um, all those textures then become like way more scrunched. Is the best word I could describe it with. Like you can only go so big because there's a limit to how big the texture can be. Like you can't have a 50,000 pixel by 50,000 pixel image texture. It's not going to work. It's going to balloon the data usage. So the solution to it was to make a grid of world canvases. Think like an image that has like 7 images interposed over top of each other in a grid. 5 by 5, 10 by 10, however big the world ends up having to be. Fine and dandy, except the entire infrastructure up until this point was using a single world canvas structure. So all of the queries, all of the particle painters were like, oh, what's the first um, paint query script in the scene? We'll use that one, which worked well when there was only one. But now there's a lot more than one, which means we had to introduce routers, basically scripts that go, hey, what's your world position? And this is the world canvas that you're supposed to be on, and this is the paint query tied to that world canvas that you can query into. Think of it like a phone call, and you're put on hold, and you're routed to the correct world canvas, and then it spits back an answer. It's like, hey, you're at yada yada 50, 60%, what have you, dirt coverage underneath you. And that's just the query. There's also the paint compute router. You need to know which world canvas you're supposed to be drawing on, which is pretty fundamental. Um, and there were many, many bugs that sprouted from this infrastructural change. But here, I'll play the game, and I know there's still a couple bugs. The first and foremost being probably the most visible on the screen is a seam, an annoying, visible seam between the world canvases. I'm going to fix it. I haven't fixed it yet, but you can start to see where I'm going with this. So, right now, a whole bunch of world canvases just spawned. You can kind of move around, and if we paint over them, it kind of goes away a little bit. But over here, we have our object world canvases. If I zoom out, right now it's this big. This whole grid. And we're in the intersection of section 00, -10, and two more below us. -1, -1, 0, -1. Now, if we move out, we'll start creating new world canvases as we move. So, for example, if I were to select you and I unpause and I start moving west for a long time, you can see it's over there. We generate more world canvases, and you can see them spawn in. I pause. And there's our new ones. 1, 2, 3, 4. And now it encompasses all of them. That process takes a lot of CPU. But ideally, the rate of expansion is not, what's the word for it? It's not exponential. It's linear. So it shouldn't be too big of a problem since, world canvases are gigantic. And in the game, you wouldn't really be able to do what I just did, which was just move left for eternity, because you'd be basically stopped by your health depleting rapidly. Right now, I have the health set to like 4,000, and your movement speed will be reduced. Anyway, each one of these is a world canvas that used to be the size of the original, what was seen in showcases and all that. And you can see, if I zoom in on our lovely player, they are massive, but it needs to be more. We need a lot more of them. So that's the bulk of what was done and implementing this system, which you can see has many scripts needed to make it work. You have the paint tiled manager for putting them in the right spot. You have the compute router for determining where the paint should go. Canvas revealer for spawning new ones. registry, whatever. It's a big system. I won't get into the weeds too much about it, but there's our query router. Um, anyway, so with that, um, that's one aspect. The other big uh, claim to fame here in this um, update is the saving and loading of our world canvases, and by extension, the um, energy probes, which I'll show you really quick. So as we moved left, you can see all of the energy probes that lazily generated on our path. Now, I'm going to start this process. This is not, so the saving process will take a hot second. If we come to our save and load and we save all, I unclick this, give it a minute. It's going to take a hot minute. This process will have to be made more efficient. I know that's soon to come. This system is very new, because it's got to save masks, a ton of masks for all of the world canvases. So you got to remember, each world canvas is 2048 by 2048, 1,000 meters. Remember. Oh my goodness, and it's back. Okay, pause. So now it's saved. 2048, 2048, and each of those singular world canvases, so again, all of these have 7 masks, and each mask is that 2048 by 2048. So you do the math, ton of masks, ton of saving. That can be broken up so it's not in a single frame. I know that'll be fixed soon, but that's what it does right now. So now if we exit play and we start it up again, let me pause. Now we're back to our original state of world canvas eye, the square. We didn't go left yet. And we load and unpause and give it like 10 seconds. We are back to where we were. And our energy probes are all still here. All the way to the very end. Though it would appear I have spotted another bug. It just seems endless, doesn't it? Or if I spawn new world canvas eye whilst in play, it does not seem to save the new one. All right, well, I'm going to have to fix that next. You can see the endless purge, the endless, what's the word for it? Grind. There it is. The endless grind in this process. But yes, that is most of what was done this sprint. A lot of under the hood stuff, too, was done. Design for the mini map and the section selector from the main menu. That is soon to be implemented. I know what it's going to look like and how to implement it. Just got to do it, which has to happen after the fundamental problems are fixed. So, thank you. That is the October sprint. I probably missed a few things, but those are the big takeaways. So, there you go.